Hello, math friends. Welcome back to A Squared Math and Stuff. In this lesson, we are continuing our introduction to limits, and we are now looking at limits that fail to exist. And there's three behaviors that we have these certain circumstances where we don't have a limit. So the limit will fail to exist or it does not exist. The first one here, I have at the very bottom of your screen here. F of x approaches a different number from the right side of our constant than it approaches from the left side of c, our constant. So this first graph here is an example of this. We are going to compare the left side and the right side and what's going on. So there's a notation that we have to introduce to you when we are indicating if we're coming in from the positive side or your right-hand side, and if we're coming in from the left-hand side or your negative side. So we are going to take a look at the limit as x approaches. We're going to look at 0 here because we see we have a jump between our values here. So we're going to look at a limit as x approaches 0 of the absolute value of x divided by x. But I only want to look at the values as we come in from the positive side. So I want to completely ignore everything that's on this left-hand side or coming in from the negative side. So this plus sign in the exponent position of our constant indicates that we're coming in, we're following our graph from the positive side of our x-axis. And then I want to also look at the limit as x approaches, let me move that over, the limit as x approaches 0, and this time we're going to come in, we're going to follow this line coming in from the negative side of our x-axis. So again, in that exponent position, we're going to indicate that with a negative sign that we're coming in from the left. So we're looking at the limit of the absolute value of x over x. So what's going on with these? All right, following in this graph coming in from the positive side until we hit an x value of 0, we hit a y value of 1. So the limit as x approaches 0 from the positive side of absolute value of x over x is equal to 1. Looking at coming in from the negative side, so follow our line coming in from the negative x-axis and approaching 0. Once we hit that x equals 0, what is our y value? Well, our y value here is -1. So because these two values are not the same, we have a -1 and a +1, the limit does not exist. We have to have the same values coming in from the negative side and from the positive side, our left-hand side and our right-hand side. So this limit does not exist, and that's because we have this jump, we call it jump discontinuity here. The second behavior is our unbounded behavior. So let's read that. F of x increases or decreases without bound as x approaches some constant c. This graph that I have here to demonstrate, we have 1 over x squared. If we again look at the limit as x approaches 0 from the positive side and from the negative side, we need to see if we have the same value, the same y value that we're approaching. So limit as x approaches 0 from the positive side of 1 over x squared, and the limit as x approaches 0 from the negative side of 1 over x squared. What do these equal? Follow this graph coming in from the positive side, and what happens is we continuously go up and up and up and up and up forever, right? Really, really quickly. So there really isn't a limit on here. We don't have a y value that we can reach because we're looking for y values when we're talking limits. So let's take a look at the left-hand side coming in from the negative side, and I follow this graph. We continuously get larger and larger infinitely, and that's the reason this graph here does not exist, because we never ever reach a y value, and we don't reach the same y value because we continuously just go up and up. So as we get closer and closer to a specific number, which is 0, our table, if we looked at the table, the numbers would just get bigger and bigger and bigger infinitely. So they wouldn't be approaching any specific number. The third case here is when we have an oscillation. So f of x oscillates between two fixed values as x approaches some value c. The graph that I have here for you to look at is the f of x equals sine of 1 over x. And again, we're going to look at as x approaches 0. And if we approach 0 either from the left-hand side or the right-hand side, what happens is we oscillate back and forth between 1 and -1. 1 and -1, no, 1 and -1, 1 and -1. And these, again, you can check it on a table, but you'll never, ever be approaching the exact same number just because it just jumps back and forth between 1 and -1 for our y values. So that is why this is it does not exist as well. So let's take a look at a few examples of just analyzing graphs and figuring out if the limits exist, and if they do, what is the limit? For these first few examples, I have the exact same equation and the exact same graph. What differs, though, is the limit that we are approaching. We have to be really careful when looking at these because sometimes we automatically assume a number that we're looking at based on the graph. But that doesn't mean that you're looking at that specific point. So what I mean by that is as you get used to understanding this, we sometimes automatically assume that we're going to look at the limit as it approaches this hole. That may not be the case. There's an infinite set of numbers that we can look at here. But for this one, we are approaching -2 from the left-hand side and from the right-hand side. So -2 is our x value that we're looking at. So let me draw a dotted line there. And what we need to do is we need to come in from the left-hand side and the right-hand side and see if there's a common y value that we get closer to. So even though there's a hole here, which means we don't have a value at -2 because we'll end up with a 0 in the denominator, we do have a hole because it's a rational function and that would cancel out. So even though there's a hole, there can still be a limit. And there can still be a limit because as we bring our pens here together, coming in from the positive side and the negative side, as we get closer to x equals -2, are they approaching the same y value? That answer is yes. They are approaching the value of -4. So the limit as x approaches -2 of x squared minus 4 over x plus 2 is -4. Let's take a look when x approaches +2. So +2 is right here. As I come in from my left-hand side and my right-hand side, am I getting closer and closer to the exact same y value? Will my pens touch? And the answer to that again is yes. But this time our limit is 0. We are approaching a y value of 0 here. So this limit is equal to this limit is equal to 0. Let's go ahead and look at a few more examples. When analyzing the graphs, they tend to go fairly quickly. It's just understanding what you're reading on a graph. All right, I again have two examples, exact same graphs, different values, different c values that we are approaching. Limit as x approaches -2 is the first thing we are looking at. So -2, I like to draw these lines so I can remember where I'm looking. As I come in from the left-hand side and as I come in from the right-hand side, do I have the same y value? The answer to that is no, because coming in from the left, the limit is equal to 1. That's our y value. Coming in from the right, the limit is equal to -1. Because these values are not the same, the limit does not exist. So not the same. Therefore, the limit does not exist. Now let's take a look again. Exact same graph, exact same equation. We're changing it up to a +2 that we're looking at. Wheel, look at that. I didn't include +2 on this graph. So let's change that to a 1. Since we have 1 on this graph, we're going to approach x equals 1. So let me draw my dotted line at x equaling 1. Come in from the left. My graph is approaching 1, or it's consistently on a y value of 1. Coming in from the right, my y again is 1. So because we have equal numbers on the left and the right side, we do have a limit, and that limit is 1. Let's quickly look at a few more examples so we can give an example of the other 2 types of behaviors. The first one here, for example 3, we're looking at a tangent graph and the limit as x approaches pi/2. Pi/2, there's an asymptote. And anytime we have an asymptote, we have to look at the end behaviors. Is it going off into infinity? In this case, yes, we have a positive infinity and a negative infinity in terms of our y values. So this is a does not exist. Anytime it's unbounded like that, either in the same direction or opposite directions, the limit does not exist. Let's look at a parabola. Parabola opens down, x is approaching 0. 0 is our y-axis. So let's draw that line. Let's take a look coming in from the left, from the negative side. We are approaching a y value of 2. Coming in from the right-hand side, the positive side, we are again approaching a y value of 2. We have the same values, therefore we have a limit of 2. Very last example I have for you is an oscillation. So we are looking at 2 cosine of pi over x, limits approaching 0. At 0, we have this serious oscillation going on, so this is a does not exist. Again, be careful, because if we were looking at the limit as x approached, say, -2 of 2 cosine pi over x, coming in from the left-hand side and from the right-hand side, from our positive side and our negative side, we would be approaching this y value here. That y value is 0. So again, you have to be very careful in regards to what the c value is, what number we are approaching. So that concludes today's lesson on limits, the introduction to limits, analyzing a graph. If you like what you saw, go ahead, hit that subscribe button down below, and I'll be chatting with you later.